basically in this data set, in this project, we are going to classify emails into two categories, that is spam and not spam. Here we are going to use this data set, that is SMS spam collection.txt. It is a txt folder. We are using some libraries, that is pandas, to read this data set, and we will be performing some basic pre-processing steps on this data set, like text pre-processing includes tokenization, stemming, lemmatization, all these things. Okay, I will cover it in details, don't worry. Then we will apply a bag of words to convert this text data into some numerical inputs, numerical data, and then we will use some machine learning algorithms to implement the entire algorithm. Okay, we will not deploy the algorithm. Basically, we will just write the code, how this roadmap actually works to implement a project. And then we will see the performance metrics, like how the model is performing on our test data. Okay, so let's continue with this. So basically, we have our .txt file, and here you can see that .txt file is not mentioned. But for your information, I want to say that .txt file can also be read using CSV format, just we need to use some separators, and we need to label the columns on our own. In CSV file, all the column names will already be mentioned, so we can directly read the data set. But in TXT file, we have to first read the data set using CSV file, and then we will use some separators. Yes, Rahul Verma, you will be provided with the TXT file after the session. You will be given the TXT file. You will be given this entire PDF. Also, you will be given the code for your practice. Okay. Okay, now we will continue with the second part, that is your regular expression library. These are some important libraries which will be used. Regular expression library, this basically is used to manipulate the text data. Basically, we have strings. It may consist of special characters. We need to remove those special characters. We will be using this regular expression library, where we'll be substituting the punctuations or the special characters with white spaces. You can see here, we have used re.sub, replaces matches with a new string. We are going to use this function for our operation, and all these things you can refer. Basically, it is not used. I have given it for your reference. You can know much about regular expression. Okay. Then we will use NLTK library. NLTK means Natural Language Toolkit. Basically, this library consists of very fascinating functions like tokenization. Tokenization means we can split the sentences into words. We can split the paragraph into sentences. This is called as tokenization. Stemming. We will cover stemming in details. Just remember this term for now. Stop word removal. What is stop word? Stop words are those words which do not carry any significant information. They are just present in a sentence to make them sound better, like the word the, this, all these words. This do not carry any significance in this sentence. If we remove these words and if we speak it with in some layman's term, then one can also understand these terms very easily. Okay, so we are going to remove the stop words from the messages or from the data set which we are using in the project. Okay, then text classification, sentiment analysis. Okay, now what we are going to do is that we are covering stop words. As I have told, stop words are the most common words in a language that usually do not carry any important meaning. So why do we need to remove them? To reduce the noise in text data. Noise basically means irrelevant or meaningless information, and decrease the dimensionality of the data. This is a very important term, that is your dimensionality. What does that mean? See, in while converting the text data into some vector, we are declaring the dimensions of the vector. Okay, dimension will be dependent on the vocabulary size. Vocabulary means unique words. Okay, so if the stop words will be present in our paragraph, then the vocabulary size will be very large, and we cannot really define this dimension properly. It will be a very big operation. It will carry very high computational expenses. It will take very long amount of time for processing. So therefore, we remove the stop words in order to decrease the dimensionality and improve the model's performance in many NLP tasks. NLP means natural language processing. The sentences or the language which we humans communicate with each other. This is just natural language. Okay. Then stemming versus lemmatization. I want to explain this in details. Like, what is stemming? Stemming basically means, do not go with the definition. I will just give you a simple difference. Stemming basically means from a word we will remove the prefix or suffix and we will get a new word. That is called stemming. And what is lemmatization? Lemmatization basically means a word is going. If I will remove the ing part, it will become go. So basically, going is converted to go. So go is the root word. So basically, a word is getting converted to its root form. That is called as a lemmatization. I'll show you with a code example. Okay, see, uh, we have this list of words. Okay, that is eating, eats, eaten, writing, writes, programming, all these things. We have imported from NLTK.stem. We have imported Potter stemmer. Potter stemmer is basically used for stemming. So we need to initialize it first. We have initialized it to a variable PS, and we are iterating through every words in this list. For each word, we are getting the output as eating getting converted to eat, eats getting converted to it. But you can notice that this word history is getting converted to this one, HISTORI, which is not correct. So basically, stemming has a problem within itself. So to fix this problem, we have used lemmatization. But in our project, we will use stemming only because lemmatization actually takes a very long processing time. So to save some time, and for this project, Potter stemmer will work fine. But for upcoming projects, if you want to build some good projects for your resume and all, you need to learn lemmatization also. So lemmatization is just like stemming. But in lemmatization, what we do is that we import WordNet lemmatizer and uh, we will provide a post tag. What does this mean, post tag? Post tag means in what format you want to treat a word. Basically, this word going, it can be treated as a verb, it can be treated as a noun, it can be treated as an adjective. Okay. So, in what format you are treating the word, the model will transform the word according to the post tag. If the post tag is verb, okay, let me execute this all the files first. uh, I will just run these files. It may take some time. No, it will not. It is working fine. Okay, see. Okay, so lemmatizer, wordnet lemmatizer we have imported. We are converting this word going and we are using post tag as verb. Let's see what we will get. We are getting go. Okay, let's change the post tag to n, means noun. Let's see what we are getting. Going, see, there's no difference. Like, going is a verb, we as humans know that, but computer doesn't know. So therefore we are providing a post tag. If we convert the word going, if we treat the word going as a noun, then it will not get converted to any form. It will be only treated as its root manner only. As a verb, if it is treated, then it will be converted to go. So all these words which we have taken in stemming, we will also convert it through lemmatization. Let's see what we will get. And we will use the post tag as verb only because it's the best one. Eating gets converted to eat, eats get converted to it. You can see that history is getting converted to history only. It is already in its root form. So it is not getting transformed. Okay. Now you can see if we are using the post tag as noun, this for word in words is just iterating through each and every words in the list. Okay, this is not a very big task, so I'm not mentioning it. I'm just covering the essential topics. So post tag, if I treat it as noun, then you can see eating is not getting converted to eat. Just in the previous case, eating is converting to eating only, like it is not getting transformed. So it post tag plays a very important role in lemmatization and stemming. Okay, not stemming, only in lemmatization. So this was all about stemming and lemmatization. I think I have made you clear. Okay. If you have any doubt, we will cover it at the end. But for now, we will continue this session. After that, we have bag of words. See, we have already pre-processed the text. Now, till now, we have pre-processed the text. Now, what we will do, we will convert the pre-processed text into some meaningful vectors. Okay. To do this, we will use a concept called as your bag of words. There are many concepts like TF-IDF, bag of words, one-hot encoding, what to vec, all these things. But bag of words is a simple one and it works well for this project. So what bag of words mean is that it is a technique used to convert text into numerical features, as I've already told. It counts the frequency of each word in a document, like how many times a word is getting repeated in a paragraph. It ignores the grammar and word order. Basically, it focuses on word occurrence. See, you can see this example. I love playing football. Football is a great game. You can see football is occurring 3 times. The frequency is 3. So if we define the vocabulary, do you know about vocabulary? Vocabulary means unique words. Unique words, if I will tell it in more simple manner, like see, the football is a single word and it is appearing 3 times. So we do not need to write the vocabulary. So we do not need to write this word 3 times in the vocabulary. Just one time we will write, it will work fine. And you can see it is in capital letter, the F word, and here the football is in small letter. So basically these things will be adjusted. We will convert the text into lowercase first. Then we will apply bag of words. Okay. So see, this is our vocabulary. In this 3 sentences, we have 11 unique words. I love playing football. Is a great game. Do not like. Okay. All the unique words have been captured. Now, with respect to this vocabulary, we will vectorize the sentence or convert the sentence into some meaningful vectors. How it is done? See, this is our first sentence. I love playing football. I is in the first place. You can check the vocabulary. I is in the first place. We will match the vocabulary and the sentence. The word I is also present in the vocabulary. The word I is also present in the sentence. So we are placing a 1 in this place. The word love is also present in both the sentence. So again, one more 1. Playing football is both present. So 2 more ones. Is not present in the sentence. So therefore, it is treated as 0. So basically, we are comparing the vocabulary with the sentence and we are checking whether it is present or not. So this is all about bag of words. Okay, now we are good to go and continue this project. Okay, we have covered the basic parts. Now it will be very interesting to do this project. We'll move a little fast. Basically, we have to wrap it up within 1 hour. Okay. So first thing, we have imported this data set using some pandas, and I have stored it in a variable that is messages. To check whether this is properly stored or not, I have imported, I have declared the head of the data set. You can see this separator /t is also used. This is to separate the label and messages, or else it will be treated as one column only. If I will show you the txt folder, you can see there is nothing, no labels in this data set. Okay, here ham and a space is given, then the sentence is given. So basically, to separate these 2 sentences, we are using /t. /t is a escape sequence for tabbed character. Okay, without it, pandas will treat the entire line as one column and we will not get 2 separate columns. So after that, we are naming the columns. Okay, this is a simple task. Then we are checking the shape of the data set. Basically, 5572 messages are there. Okay, after that, we have imported RE. RE is your regular expression library, and it is used to remove the punctuations, white spaces, to compare some text in strings, all these things. NLTK, we have already discussed, for perform lemmatization, tokenization, all these things. So basically, first we have to download the stop words. What all stop words have been defined by the NLTK library, we have to download. You can also declare the own set of stop words. But see, stop words, there are various stop words in English dictionary. Okay, so you can't really declare it on your own. It basically takes a lot of time. Then we will check for none values. This is just pre-processing, basic pre-processing we are doing. You can see there are 0 null values in the data set. And if you check the information of the data set, you can see all the classes are in the present of object data type. Our main objective is to convert this object into some numeric data so that the machine learning algorithm will be able to understand. Okay, machine learning algorithms cannot understand text data. If we direct feed this data, then it will not be able to perform anything. We need to vectorize these sentences first. Okay. So you can see all the examples of the stop words. Basically, stop words is equals to, in this way, if you want to view the stop words, you have to use this statement, that is stop words dot words English. You can check out for any other language like Arabic, French. I don't think Hindi will be there because it's I've already tried it before, so I don't think it will be there. For now, English we will see. You can see all these stop words: a, about, above, after, again. If these words are present in the sentence, then we are going to remove it. Okay, our main task will be that in our text preprocessing. Okay, so we will move ahead to the text preprocessing. This is just importing all the libraries, stop words, stemmer. I've shown you the example. We have used Potter stemmer. First, initialize the Potter stemmer. So PS is equals to Potter stemmer parenthesis. In this way, you need to initialize it. Okay. This is the main part of text preprocessing. Understand it carefully, guys. Okay. We have all the messages. We have 5572 messages. We are going to pre-process all the text and store it in this list, that is your corpus. So we have declared a variable, that is corpus, which will store the list of messages. What messages? Cleaned messages. The messages obtained after all the pre-processing steps. So basically, we are iterating through every messages from range 0 to len messages. Len messages means 5572. The value of len messages will be 5572. You can see the data frame with shape 5572, 2. So basically, from 0 to 5000 times we are going to iterate. Okay. So in the first iteration, the value of I will be equals to 0, means it is going to access which message? This message, that is go until Jurong point crazy, this message. This does not make any sense. Just for example, I have shown this data set. Okay, so we have our first message. What we are going to do? First, we need to remove the punctuations. So to remove the punctuations, we will use this function, that is re.sub. What does this mean? Small a to z, capital A to z. It means that if in this sentence you find any character other than small a to z or capital A to z, replace it with white space. You can replace it with some digits also. If I will write 0 here, it will be replaced with 0. And if you also want to if you do not want to remove the digits, if they are okay, if they are present in the sentence. Okay, so if you want to remove the, if you do not want to remove the digits which are present in the sentence, you can also add here 0 to 9 also, like this you need to add. But basically I'm not going to edit this code now. So we are going to apply this message in this part, that is messages of message of I. That means our first message, that is go until point Jurong, is going to access, and all this substitution will going to be applied here. After that, the punctuation is removed. Now we are going to convert the text which from where the punctuation has been removed to lowercase. That is review is equals to review dot lower. This is very simple. Then we have the sentence. We need to split the sentence into words. Basically, these words do not have any special characters. All the words will be in the present. All the words will be in the lowercase, as we have performed these two operations above. So basically now what we have a list of words. This list of words, we are going to perform stemming. But before stemming, we have to check whether these words are present in stop words or not. If the word is not present in stop word, then only we are going to perform stemming. And if it is present in stop words, if it is an unnecessary word, we are going to remove it. So basically, if we have 50 words in this list, we are going to iterate through every word in this list. That is for word in review. If not word in stop word, basically means if that word is not present in stop words, means word is not a stop word, then apply stemming on this word. Okay. So after 50 iterations, if there are 12 words, 12 stop words, then we will get 38 stemmed words. 38 words which have been converted to their stem format. Okay. Then review is equals to blank space dot join review. We have the list of cleaned words. Then we are converting, then we will be joining them into another sentence, into a single sentence. Okay. Then we will add it in our corpus. So this is all about the text pre-processing part. You can ask your doubt in the chat box. I will answer it. Okay. You have 5 minutes. We can cover the doubts. Okay. Go ahead, guys. You can ask some doubts. If you want, I can turn on the mic. Let me allow you to turn. Okay, it is already on. You can ask your doubts. No doubts. Everything is clear. Okay, Q&A, we have some questions. Will we be provided with recorded? Okay, you will be provided with a recorded video session. This was a very early. Okay, so if you do not have any doubt, let me ask some questions. Okay, can you explain the review part? Okay, let me explain this review part again.
रूम ताने से डन with
Anil, please turn off your mic if you do not have any doubt. Yes, thank you. Could you please repeat stemming? What is bag of words or TF-IDF? See, bag of words or TF-IDF, we have not come to that topic. I will discuss it. Let me explain the stemming part again. See, stemming is basically we have our word. We are converting it to its stemmed word by removing the prefix and the suffix. Okay. This word eating, if I will remove the ing part, it will get converted to eat. You can see it here. It's the s part is getting removed and we are getting eat. So basically we are removing the prefix and suffix and we are getting our new word that is called as your stemming. That is the process of removal of prefix or suffixes to get a new word, so that we can reduce the size of the word and we can convert it into vectors more effectively. Okay, this programming is getting converted to program, history is getting converted to history, all these things. Okay, TF-IDF is usually better than bag of words for most NLP cases. Yes, TF-IDF is generally better for most NLP concept because it provides more meaningful reply. Yes, see TF-IDF in a bag of words, there is only zeros and ones present. But in TF-IDF, you will get some values. You will get some dependency. Like this word, how much dependency it have on the vocabulary. You will get a particular value. If the value is close to 1, then it will have a higher dependency. And if it is close to 0, then it will have a lower dependency. Basically, you can get the semantic information captured from the sentence if you are using TF-IDF vectorizer. And if you do not use TF-IDF and you are using bag of words, then you may not capture the semantic information. You are only going to capture whether the word is present or not. Means you are only capturing the occurrence of the word. Okay. So for stemming, we need to import some libraries. Yes, you need to import NLTK library, and in the NLTK library, you need to import Potter stemmer, where you can perform stemming operations. Okay. What happened in re.sub? See, in re.sub, let me go to that part. Okay, re.sub, we have our message. Don't just think about the data set. Think about a string. You have a sentence. There are many punctuations in that sentence. You need to remove that punctuation. So what you will do, we are using re.sub. Basically, in re.sub, we are checking if in that string any character, if in that string any character other than small a to z or capital A to Z are present, remove that character with some blank space. Means if any digit is present, it will be converted into blank space. If any exclamatory mark or special character is present, it will be converted into blank space. Okay. I think it's clear. Yes, thank you. Okay, got it. Can we get the txt file? Yes, you will get the txt file at the end. Could you please repeat stemming? Yes, I've covered this. What is better, bag of words or TF-IDF? TF-IDF is better. I have to work on this project before taking the questions. Okay. Can you explain the review part? Yes. Okay, see, we will go through this review part again. This is, in this part, what we are doing is that you need to understand, we are pre-processing the text. First, let me show you the original text. You can see the text, go until Jurong Point crazy. Remember this. Now I will show you the new text. You can see the difference. See, go until is removed. Jurong Point crazy. Crazy spelling is changed. Available spelling is changed. Avail it is. And budgie and great, some transformation has been occurred due to stemming. Okay. So what we have done is that we have first taken the sentence, we have removed the special characters, then we have lowered the sentence, then we have split the sentence into a list of words, Then we are iterating through the list and we are checking whether the word is present in stop word or not. If the word is not present in stop word, we are performing stemming operation, and then the word which has been performed means the word which has been stemmed is then appended into a new sentence. The sentence thus formed is then added to the corpus through the corpus dot append. In this part, we are forming the sentence, that is this sentence. Go Jurong Point crazy. This is the sentence. This is one sentence. We will append it to the corpus. Similarly, for I equals to 1, this is for I equals to 0. Then I equals to 1, we will get another sentence, that is okay lair joke uh, wifu only. This doesn't make any sense, but this is some transformation. You may not understand this sentence, but the model will be able to understand when we will convert it to vector. Okay, so now this transformation has been done. Okay, so we will move ahead with further topics in this project. So basically we have converted the text, that is pre-processed the text, not converted, we have pre-processed the text into some simpler format. Okay, now what we will do, we will apply bag of words. You can also apply tf-idf. I am applying bag of words. I am applying bag of words. Okay, you can apply tf-idf. Let me, okay, one doubt I can see, that review is equals to dot join corpus, not dot join corpus. It is dot join review. We are adding the list of words into a sentence. We are converting the list of words into a sentence. Corpus is a empty list where we are adding the sentence after we have combined the words together. Okay, first we are combining the words together and then forming a sentence. After that, the sentence thus formed is then appended into that list, that is your corpus. Okay, so let me ask you one question, like are you familiar with bag of words? You can ask in the, write it in the chat box, or you can open your mic and say. Quick guys, we will move ahead. Yes, only one. No, no. Okay, some are saying no, some are saying yes. Okay, many are saying no actually. So let me explain this bag of words again. Okay, we'll go through this bag of words. Okay, before bag of words, I want to ask one thing, that is, are you clear about vocabulary? What does vocabulary means? Yes. What is this parameter n-gram range? Wait, we will discuss this. No, just 5 more minutes and you will understand everything about bag of words. See, these are NLP concepts. You need to understand NLP in deep so that you can implement all these concepts. We are implementing this project using NLP because we have some text input. Okay, uh, so you need to understand NLP first. Here in this session, we are not going to cover the entire NLP. Rather, we are trying to make some part clear so that you can access this project. You can understand the roadmap. Okay, I think you are clear about vocabulary. See how bag of words work. You can see the size of this sentence, that is size of this vector 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The vocabulary size is also 11 and the vector size is also 11. So basically, arrange this vocabulary in this manner. Like I love playing football is a great. This is the vocabulary arrangement. Take a sentence. I love playing football. Compare the words in the sentence with the vocabulary. You can see the first word I is at the first place in the vocabulary. So in the vector transformation, we are applying 1. Love is at the second place, so we are applying 2. Playing is at the third place, so another 1. And like this, football is also present, so another 1. After that, we are getting 0, 0, 0, so many zeros, because all this is a great game, do not like. This all words are not present in the this sentence. So therefore, the bag of words is converting that vocabulary into 0. So basically, all these sentences will be converted into a fixed vector size that will be equal to the size of the vocabulary. If the word present in the sentence is present in the vocabulary, then in place of that word, we will get 1. And if it is not present, then we will get 0. This is just a simple transformation where ones and zeros are getting placed, and if it is not present, then 0 will be placed. Do you understand now? Bag of words. Yes, yes. Okay, so we'll move ahead. Let me show you this practical example which I have written for you, the bag of words. You can see from sklearn.feature extraction, import count vectorizer. Count vectorizer is the function which we will use for bag of words. And this is our corpus. Corpus, don't bother about the word. Corpus is means paragraph. It is a variable. We can write it. I can write my name here also. Okay, it can be anything. So I love playing football, all these words. Vectorizer is equals to count vectorizer. This means that we are initializing it to a variable vectorizer. Then what we are doing is that we are applying the bag of words in this corpus. Fit underscore transform means apply bag of words in the corpus. Okay. See, you can see the definition. Learn the vocabulary dictionary, that 11 words, and return document of matrix. This is equivalent to fit followed by transform, but more efficiently implemented. Okay. If you will see the vocabulary here, the model has written the vocabulary like this. In the PDF, we have different vocabulary. Here we have different vocabulary. This is not a problem. In this way, it is only arranged. Okay. You can see the vocabulary. This is the vocabulary. And besides it is written the index like 6. You can see love is present at the 6th index. 0, 1, 2, 3, 4, 5, 6. 6th index. Okay. Now we'll move ahead with our project. So basically in the example, how we have done is that we have implemented the count vectorizer, that is your bag of words, and we have used a n-gram range that is equals to 1, 2. What does that mean? What does that mean? N-gram range. Are you familiar? Tell me. If anybody want to answer, then it is very well. Okay, I will explain you n-gram range. See, you have this 3 sentences. I love playing football, and the vocabulary is I love playing football. You can notice one thing is that all the words in the vocabulary are single words. Okay, so one question may rise is that can we not do 2 words in the vocabulary, like a combination of 2 words in a vocabulary? Is it possible? Combination of 3 words in the vocabulary, like I love playing, will be considered as a 1 unit only, and football is considered as a 1 unit only. Is it can be done, right? So it is done through n-gram range. Basically n-gram range, if we are using, what happens is that the vocabulary which is getting created will consist of both single words and double words. Okay, and the maximum number of features which I have mentioned it to be 2500. See, we have this data set. It consists of, if I will calculate the vocabulary size of the data set, then it may exceed 10,000. So we cannot use that much amount of vocabulary. We are using the top 2500 vocabulary. That is, the vocabulary is always arranged in terms decreasing order of frequency, in decreasing order of appearance. Okay, how many times a word is getting appeared, that will be maximum frequency and it will be placed at the top, and the one with the lowest frequency will be placed at the bottom. So first 2500 vocabulary we are using, and n-gram range equals to 1, 2 means we are taking a combination of single word and double words. You can see, if our vocabulary I want to see, let me skip some part. I will come back again. You can see the vocabulary size is, see, there are words like. Okay, like is present at the 1169 index. Fun is present at the 775 index. And you can see some words will have combination of 2 words. Basically, I'm calling, see, set color tune. This is a combination of 2 words and is present at the 1851th index, 1851 index. Press copy. The spelling is copy is wrong because we have performed stemming. Therefore, it has been transformed. It is present at the 1657 index. Basically, the vocabulary is now a combination of both single words and double words. Okay. Why do we do it? Because some words do not rely any information or implement any information on their own. If they combine with some other words, then it may happen that they implement some information. Like you are lucky. If these words are separated as their own, then it may not implement any information. But if they are used together, you are lucky. It relies some information. You need to capture that information from your model. Therefore, you are using n-gram range to be 1, 2. If you will use 1, 3, then it will have a combination of single word, double word, and triple word. Do you understand? About n-gram range, max features, and bag of words we have already discussed. Okay. So now what we'll do, just a second, guys. Okay. So now we will apply this bag of words which we have created. Combination of words that is both single and double words. Yes. N-gram range. Combination of words that is both single and double words. Combination of vocabulary which consist of both single and double words. So what two words are able to be considered together, the program will decide. Yes, the program will decide according to the frequency. Means if two words together are appearing, means you are, if these two words are appearing repeatedly, then the program will capture it. I have told you the max features is 2500. It will take the top 2500. Okay. Then max feature is number OG unique words we are taking for vectorization. Is it right? Yes, max feature is the maximum number of unique words. This is correct. This is basically the unique words are arranged in decreasing order of their frequency. From the top, we are taking 2500 words. Okay. So I think I've covered all the doubts. Any more left? Let me see. Combination of words? No. So we'll move ahead with the project. Then see X. What is X? This will be our independent features, and Y will be our dependent features. Independent means the input column, and Y dependent means our output column. Okay. Till now we have not approached the output column. We are only doing till we are only doing the input column only, but we will speed up. Don't worry. We'll cover this more. 15-20 minutes will take. So cv.fit underscore transform, basically the bag of words which we have created, we will use it in this entire corpus which we have created. This is a very big corpus. When I will provide you with the code, you can see how long will it take to scroll down entirely. Okay. I am doing this because I am scrolling outside of the code. Therefore, it is not taking that amount of time. But when you will enter into the text, then you will see how many sentences are there. 5000 sentences are there. Okay. So we will apply the bag of words. You can see there is a matrix of zeros and ones created. It will be created here in just in this format only. It will be created, but you can't see the ones. Why? Because there are 5000 features. Here we cannot actually denote all the 5000 features. See 000 in this between dot 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 are there. This dot consists of more than 5000 features. So basically we cannot add all this, show all the ones in this feature. You not need to just imagine it like the sentence will be get transformed. You don't need to actually see the sentence. The model will understand what you are doing. So basically after applying the bag of words, what we are doing is that we are viewing the bag of words, that is implemented bag of words. We are just depicting the implemented bag of words in the form of array. This part is nothing important. If you remove this part, it will not create any significance. I have just added it to see the array which is getting created, like how many zeros are there. See, I have 30. Edge items equals to 30 means in the starting and ending, we will have 30 zeros. And line width is equals to 10,000. This basically means line width means it basically selects the maximum number of characters per line. And np.print underscore option, it is basically a numpy function which is used to view a array. If you will remove it, then also it is not going to affect the program. Okay, see how many there. If I am going to scroll it, it will take a long amount of time. Then I have discussed this vocabulary. See, let me check the maximum frequency word. See, go is the maximum frequency word which is present at the 819th index. You cannot see the frequency, but you can check with which word is appearing the maximum number of times. Go is first, then point. Similarly, if you go down, you will see some two words combined together. See, entry, WKLI. This is transformed, therefore it may not be able to understand, but this is appearing so many times, therefore it is present in the vocabulary. Okay, can you please add me in the data science group? Sure. Then y is equals to pd dot get underscore dummies. Why? So now what we have done is that till now we have covered the entire input part. Now we are going to address the output part. You can see the output part. Let me go to the top. See, we have a label where we have ham, spam, all these columns. Basically, we will take any one column. We have one column. First, we will convert it into two columns. How it is done and why it is done, I will show you. See, y is equals to pd dot get underscore dummies. I am converting this label column into two different columns, that is ham and spam. Okay, so ham basically it will be true when y will be equals to 2. This messages of label when it is ham will be true in this section. Like let me go to the top. See, we have ham, ham, spam, ham, ham. Okay, remember this. Ham, ham, spam, ham, ham. Okay. And let's move to the this part. You can understand it by example only. There is no such explanation to this. Okay. See, we have ham, ham. So in the ham column, we will be having true, true, and false, false in the spam. Then we will have then in the in second index we have spam as true, and then in third and fourth index we have ham. So therefore true, true. So basically we have converted the ham and spam into two columns where true and false will be represented. If it is true, then it is a spam, and if it is a false, then it is a spam. Okay. Both ham and spam cannot be true together or cannot be false together. If one is true, then other one has to be false. Okay, this is very simple. Y is equals to y dot ilock. What does this statement means? This statement means we are taking only the first column. You can take the spam column also. This is just vice versa. Okay, but we are taking the ham column. You can see true, true, false, true, true. Basically true, true, false, true, true. This means we are taking the first column. Now this is also in the form of integers. Sorry, this is also in the form of text. We need to convert it into some vectors, meaningful vectors. So we will convert the string into vectors. That is y is equals to y does as type integer. This as type function converts string. If we have a binary string, means only two categories, true or false, yes or no, or any other category, whatever you want to take, pass or fail, yes or no, anything, it will convert it into integer with true as 1 and false as 0. Okay, so basically our independent features are also converted into vectors, our dependent features are also converted into vectors. Okay, now we will check the safe, that is 5572. This will not change, of course. Till now you have any doubt, you can ask. Then we'll move to train test plate. What is need for dummies? See, we are separating the two columns into true ham and spam. Na? Therefore, we are using dummies. Okay. Or else we cannot separate it. If we do not separate, we cannot access any one of the column, and we cannot convert it into integers. This is the process. Okay, you need to stick with the process. I think it may sound clear. This is simple part. This is just basic Python, NumPy only, or pandas, all that thing. Okay, so now we will just go with the train test split. You are all familiar with train test split, right? I think you will be familiar. This is fundamentals. What is the difference between dummies and label encoding? Okay, label encoding is a NLP concept. You can also use it for directly taking the true false. If we have three different categories, here we have two categories, that is true and false. If we have three categories, then in that case we will be using label encoding. And label encoding, it has one problem, right? Label encoding, what it will do is that it will assign some value to the three categories, like 0, 1, 2, and the one value which is the one category which is assigned to be a 2 will gain some importance with respect to other two categories. This is the problem with label encoding. Therefore, we are not using label encoding here. Okay. Okay, ठीक है. Okay, we will move ahead with trend test split. So tell me guys, are you familiar with trend test split? We will move fast now. We have already covered most of the topic. Just a little part is remaining. Label encoding assigns a unique integer to each category, which may imply in order. You can see the definition which Rishabh has provided. Very fine definition. You can follow up with this. You can also no, you do not know trend test split. Okay, let me just give a quick overview. Trend test split basically means we have a data set. We will convert it into two categories. One category will be used as our training data set, and other will be used as our test data. Okay, so training data will be used to train the model, and to evaluate the model, we will use the test data. Basically, you are giving an examination. You are practicing some questions on your own, and after practicing you are giving the examination. Basically the examination is your test data, and the questions which you are practicing is your train data. Okay, to evaluate the model we need to have some data points, right? If we do not have any data points, where we will bring some data is very difficult to collect. Training set 80%, test set 20%, exactly. Therefore we have test size 0.20. Okay, so basically four categories we are going to split, that is X train, X test, Y train, and Y test. Okay, what is this function doing? This is basically converting the X and Y, which is our independent and dependent features, that is our input and output column, into train and test data. For independent feature, we have train and test. For dependent feature, we have train and test. Okay, see how I will use this in our machine learning algorithm. We have implemented logistic regression. I'm not going to explain this logistic regression is now in details, because see, logistic regression is a very big algorithm to discuss. It has many mathematical operations. So for now, just understand that it is just an algorithm to classify data sets into categories. It is used for classification. It is not a regression algorithm. Regression means it will not perform any mathematical operations to relate the input and output features. Rather, it will use some mathematical operations to classify into categories. Linear regression we cannot use here, Nilam Tiwari, because it is a classification problem. Linear regression, if you will use, I'll give you an assignment. You can go ahead and try linear regression. What results you will get, you can see. You can clearly see the difference why we are using logistic regression and linear regression and not using linear regression. Okay, you can try here. Instead of import logistic regression, just write linear regression, and exactly the same code will be there. Just remove this sklearn part, that is your classification report. You will get the result. Okay, see how we are going to implement this logistic regression. As I have told, we are going to implement or train the model using the train data only. We will not use the test data. So basically our model, that is spam detect model, I have named the model, and the model which we are using is logistic regression dot fit X train and Y train. Only the train data I am giving. You cannot see here test data. For test data is basically the answers. We will use it for evaluation part. Okay, training data is for training and test data is for evaluation. So we are training the model on train data, that is X train and Y train. After the model is trained, you cannot see the model, how model is getting trained. Actually the model is getting trained in the backend. If you will understand the mathematical operations, you can relate, but in this screen you cannot, it is not visible, it will not be visible. Okay, then we are evaluating, then we are calculating some predictions, then we are making some predictions based on the test data, and we are getting the predicted values. We are writing the variable to be ypred. Now we have got our predicted values, and we have our test data with us. We have not used y test. You can see X train we have used, Y train we have used, X test we have used. What is y test used for? Y test is basically used for comparison, to deduce, to create the confusion matrix. We have already we have already evaluated the predicted values. We have our predicted values in one hand. We have our test values in one hand. Now we are going to compare. Like the test values is the correct value, and the predicted values we will check whether it is correct or not. So you can see when we are checking, the accuracy score comes out to be 97.75%. Only 2.25% is wrong, and rest all the predictions is correct. Means if you are giving any input on your own, it is 97% sure that your model will be exactly predicting it correctly. Sorry, the model will be able to predict the email it is a spam or not. You can see the precision and recall. You can see precision and recall, that is 0 it means that spam and 1 means ham. For spam emails, 99% precision, it means that all the spam emails which we are receiving is classified as spam and is not able to eradicate the eradicate the model, means it is not missing out. Means we are receiving 50 emails, 99% of all the 50 emails are classified as spam. Sorry, we are receiving 100 emails, out of which 50 emails are spam. Okay, so out of the 50 spam emails, 49 emails are classified as spam and maybe one email is considered to be not spam. So this is basically a very good performance of this model, because we have trained the model so properly that we have also used bag of words. Therefore, I have used bag of words. This code, when I was writing, I have used TF-IDF, but it did not give that much performance. TF-IDF is better, but in some case, bag of words may outperform. Okay, you need to have some NLP overview. You need to learn NLP before you can differentiate in which data set you need to apply what. Okay, so this is our model performance completely. And this is our end of the project. Basically, all these things we have done, converted the text into vectors, pre-processed the text. I think I made it clear to you in the best possible manner. I prefer that you should go and revise this code again if you do not understand. If any part you cannot understand, try using some documentation, or you can also refer chat GPT for some explanation. Like for revision, you need to revise. We will be providing you the PDF. You can also refer that part. So this was it from my side. If you have any doubts, go ahead and ask. Like the mics are turned on.